Hello. Hello, everybody. Welcome to another wonderful day of Math 211. Um, Today, what we're going to be working on is we're going to be going through the homework from chapter 9 and 10, which was on. So, sorry, reading the question there. We were reading chapter 9 and 10, which was on direct proofs and proof by contrapositive. And so, we were looking at, I had a question on chapter 8, number 2. As a note in my last lecture on 211 that you can look at earlier, we ended up going through all the problems anyway. So I'm just going to work through all of the homework problems. And if you have specific questions along the way, make sure to ask me so that I can address those. So make sure to type in chat or speak in Discord, whatever's easier for you. All right. With that said, let's suppose that x is odd. We have to show that x cubed is odd. Someone in Discord has a mic open with a lot of stuff going on in the background, just as a note. Alright, so as I look at this one, we'll go ahead and go up to the board and we'll start this proof. Sorry, I have a baby crying in the background too. Lots of stuff going on in the background. Alright, so for a direct proof, what we want to do is we have if P then Q. We're going to assume P and show Q. So our proof is going to start as assume that. And I'm just pulling this up to make sure I remember it exactly. Assume that x is odd. We want to show that x cubed is odd. All right. Sorry, I had to take care of something there. So assume x is odd. I want to show x cubed is odd. And so what I want to think about here is what are the different definitions of odd? What are the different things we can work with here? And what we have is, I'm just going to list out all the things that we have. If you guys remember any, try to write them up. But what I had was, we can either write that x is not even. We can write that x is not divisible by 2. So 2 does not divide x. Or we can write that x was equal to 2k plus 1 for some k and z. Or we could have that x is congruent to 1 mod 2. Now, if you don't remember from last Thursday, we talked about mod 2, and we said, okay, it's congruent to 0 mod 2 if it's even, it's congruent to 1 mod 2 if it's odd. If x is odd, we proved that this was true, so we proved that these things were all equivalent. So these are all equivalent statements, so I can use any of the above. To start with x is odd, I'm going to say, okay, all of these things are equivalent to that. Now, to show that x cubed is odd, I can write x cubed is not even. 2 does not divide x cubed. X cubed is equal to 2 times an integer plus 1. Or x cubed is congruent to 1 mod 2. And so somehow I have to write that out for that as well. Now, as I'm starting this proof, I'm writing down a whole bunch of different definitions. I'm definitely not going to use all of these, but I want to have them up there to think about what is the easiest way to do this proof. I'm actually going to do this one two ways for you guys. So the first one I'm going to start with is the mod 2 thing. So if x is odd, x is congruent to 1 mod 2. The reason why I wanted to do this is to show you how to use modular arithmetic, because you probably don't have as much experience with that. But what I want to get is, okay, then I have to show that x cubed is congruent to 1 mod 2. So I'm going to use the same definition at top and bottom. So the point here is to start on the left-hand side and end up on the right-hand side. Now, what I want to remember from last time was that we realized that with modular arithmetic, it respected the addition and multiplication. So what that means is if I had something like A times B plus C times D, and I know that A is congruent to something, let's say 1, and B is congruent to 0, and C is congruent to 1, and D is congruent to 1, instead of having to work through all of this and find these things and then find what it is mod 2, I can directly substitute in what each of these things are congruent to mod 2, and I can find then 1 times 0 plus 1 is 1, so the solution will be 1. And that was the big benefit about using modular arithmetic here. In particular, what that means is that x cubed is x times x times x mod 2. Therefore, this is 1 times 1 times 1 mod 2, which is just 1 mod 2. Hence, it follows very quickly that x cubed is congruent to 1 mod 2. So, if x is odd, x is congruent to 1 mod 2. Therefore, x cubed is congruent to 1 mod 2. Therefore, x cubed is odd. And so that would be one way to prove this. All right. Another way to prove this would be we could use a different definition, and we could say odd is the same as x is equal to 2k1 plus 1 for some integer k1, and I have to show x cubed is equal to 2k2 plus 1 for some integer k2. Just to make you guys do a little bit of work here, I'm going to give you a minute, and what I want you to do is try to figure out, okay, I have assume, I have my definition, assume my definition. How can I fill in the middle here? What should I do? So try to work on that. Think about what to do next, and then I'll come back up to the board and we'll do it together. Alright, so what did you guys do next? Let me know. Well, I think what we do here is I want to show this is equal to this. So I'm going to start on the left and say x cubed. And what I want is to get the right-hand side out. So I'm going to start here and I'm going to work my way until I get that out. Now how do I do that? Well, what I notice is that x cubed is, well, x is 2k1 plus 1 cubed. So I have to cube out 2k1 plus 1. Very good. Now, if I wanted to, I could indeed actually FOIL that out and then FOIL again and distribute it as I want. But I'm going to use Pascal's triangles because we know it. And I'm going to say, okay, so it's 1, 1, 1, 2, 1. And if I use cube, it should be 1, 3, 3, 1. So this should be 1 times 2k1 cubed plus 3 times 2k1 squared times 1 plus 3 times 2k1 plus 1 cubed is 1. So if I cube that out, that's what I'm going to get. This is my a, this is my b, so I get a cubed plus 3a squared b plus 3ab squared plus b cubed. So there we go. Now remember, the goal is to get it as 2 times some integer plus 1. So I'm going to have to simplify a little bit more. And if I cube this, I get 8 times k1 cubed plus 3 times 2 squared is 4 is 12k1 squared plus 6k1 plus 1. So now I want to write it as 2 times an integer squared, so I'm going to factor 2 out of everything except for the, 2 times an integer plus 1. So I'm going to factor 2 out of everything but the 1, and I get 2 times 8k1 cubed plus, that should be a 4 because I factored out a 2, plus 6k1 squared plus 3k1 plus 1. Now what we notice is, well, this is an integer, this is an integer, these are all integers. I'm multiplying and adding integers, so I end up with an integer. So this big thing is just some integer. So what I'm going to do is I'm going to let that be k2. And so what I get is this is 2 times k2 plus 1. So this big thing is just some integers, so we call it k2. So we get 2 times k2 plus 1. So x cubed is indeed odd because I've written it as 2 times an integer plus 1. Now I went through both of these to kind of actually make a point here is that the modular arithmetic one just saved us a lot of arithmetic. We didn't have to do all of this algebra and distributing and simplifying. It just worked a little bit quicker, but it is something new for you to get used to. So if you do get used to it, it just saves you having to do a lot of that work. But if you don't want to get used to it, you are more than welcome to actually do the proof this way, write this all out. I am happy either way. Both proofs are valid, so I'll take either one. So make sure though that whatever you're going to use that you practice, that you are comfortable with it as you get to things later on in the homework or on tests. Did anybody have any questions on that one? So I see a question. I'm confused. How did we get those numbers cubed? So to go back kind of over the whole thing, the idea was I want to assume that x is odd and I want to show x cubed is odd. Yeah, go ahead. Yes, I can hear you. What's your question? All right. Someone was talking to Discord saying they had a question. If you have it, just go ahead and ask. There might be a delay between me answering, but I can hear you. All right. Well, I'll go back to the question I saw typed. Was that? Oh, okay. The x cubed. Okay. So getting back to the x cubed thing, which was the question. So there we go. So with the x cubed is we want to show that this is odd. So we're taking x cubed. So that's why we have that. Now, how did I get these numbers cubed? Is I know that x is equal to this. So all I'm doing is substituting in here. So instead of writing x, I'm writing 2k1 plus 1, and then I'm cubing that. Does that make sense? All right, once I do that substitution, then all I'm doing is I'm actually distributing this out. I used Pascal's triangle to do that, but if you wanted to, you could actually multiply it out. And if you were to multiply it out, this is what we get. So we do a substitution. Instead of x, we have 2k plus 1. So instead of x cubed, we have 2k1 plus 1 cubed. And we got this because this is the definition of being odd, is these two things are equivalent. Does that help? Or did that not clear it up? All right. So there's about a 10 to 15 second delay, it seems. Yes. Sorry about that. I'm not sure why it's so much longer than usual. I'll have to work on that for next time. I'm going to try to make do with it for today so that we at least get through these problems, though. Is that all right with everybody? Well, since there's such a delay, I probably won't get an answer for a little bit. But what I will say is that I'm going to move on to the next question. And if you guys do ask questions, I will see them eventually, and I will go back to them as I see them. So I'm not going to ignore you. I will get to them, and I'll try to answer the best I can based on what I see. All right, with that said, let's suppose that we have integers a, b, and c, and I want to know if a divides b and a divides c, then can we show that a divides b plus c? So how are we going to do this? Again, I'm going to give you a second here, and I'll probably will have started by the time you get through it, but the point is I'll give you a second. What do you assume? What do you show? Actually try to write that down before we go together as a class. All right. So what we have is, again, we're going to be doing a direct proof. So we have the if part. So we get to assume the if part. So we get to assume that A divides B and A divides C. And what we have to show is that A divides B plus C. So what we have to do to work with this is we have to say that, okay, well, if A divides B and A divides C, can I show that A divides B plus C is, I want to write out, well, by definition, what are these things equal to? So if A divides B, what that means is that B is A times some integer. And if A divides C, that means that C is A times some integer for some integers k1 and k2. So we assume this is equivalent to this. In the same way, we have to show this. So this is equivalent to saying b plus c is equal to a times some integer, which we'll call k3. So now what I have to do is show that b plus c is a times some integer. So I get b plus c is, well, b is ak1, c is ak2. And remember, I want to show it's a times some integer. So I get a times k1 plus k2, which means that if we let k3 equal k1 plus k2, what we get is that b plus c is a times some integer. K3 is k1 plus 2, so b plus c is just a times k3. Hence, we get exactly what we're looking for, and we're able to show that that divides appropriately. All right. If you do have any questions, all right, going back, I see some questions. The last problem, we can use the first example. Yes, you can use any technique you want. In this case, in the second example here, I showed the division just using one technique. But if you come up with some other technique, you are more than welcome to do that. All you need to do is to know one way to prove these, and I will be happy. And so I'm trying to show multiple techniques to try to give you a chance to come up with something that's most intuitive for you and you're most comfortable with, so that you have more options in the end. But especially on a test or something, if I ask, I don't need multiple proofs. I just need one proof. All right. I'm going to try to fix the delay real quick, so I'm actually going to end up ending the stream and then restarting it to see if that helps.